In this video, we are going to learn about exponents and order of operations. First, a little bit of vocabulary. When you have an exponent, you have the base and the exponent. So the main number is called the base. That's the one that you're multiplying by itself over and over and over again. The small number up in the corner is the exponent. That is how many times you're multiplying the base by itself. And then the whole thing is sometimes called a power. But we also kind of use power to refer to the exponent part as well. But that's just another term you'll sometimes hear in there. So for example, if you had 2 to the power of 28, that would be 2 times 2 times 2 times 2 times 2, on and on and on and on, 28 times. The base is 2 because that's the number that's multiplying. The exponent is 28 because that's how many times you multiply it together. All right, so let's break this down a little bit. What exactly does an exponent of 2 mean? So if I had 1 to the power of 2, what does that actually represent? Well, we know that means 1 times 1 because there's 2 ones multiplying together. We also can model it as where you have a square with a length of 1 and a width of 1. Well, if you had that square, then the area would also be 1 because length times width is area. So 1 squared is sometimes what we call that, would equal 1. We can call that 1 squared. Okay. What if we did it with a number other than 1? 1 seems to just have a lot of ones going on in there. Let's say we did this with 3. Say we had 3 squared. Well, that would still be 2 of the number, so 3 times 3, because there's 2 of them. And this time, instead of having a 1 by 1, we'd have 1, 2, 3 by 1, 2, 3, a 3 by 3. And if we model that out, you can see that what that gives us is 9, because 3 by 3 will give us an area of 9. So 3 squared is 9. Now, sometimes you'll be asked to kind of do this backwards. So you'll be given what the value is and be told to find some other part of it. So in this case, what this is asking is what number squared equals 81, or what number to the second power equals 81. We can also visualize that by picturing a big square with an area of 81. So if it's a square and it has an area of 81, the question is, what must the side lengths be? Or what number times itself would give you 81? Well, we know that 9 times 9 gives us 81. Therefore, 9 squared equals 81, which means x must equal 9. This is also our very first introduction to this idea of a square root. So the square root of 81 equals 9. And that's all that this means. The square root is what number times itself equals that thing. All right, so what about an exponent of 3? Well, 1 to the third power would be 1 times 1 times 1. And we could draw that out by drawing a 1 by 1 square except we have 3 ones there. So we actually need to make it into a cube. So this will be a 1 by 1 by 1 cube, which is just a single cube. So that would still just equal 1. And the way we can say that is 1 cubed. What if it's not a 1 though? Let's say that we had 3 to the third, or 3 cubed. That would be 3 times 3 times 3. And we can model that out much the same way, where we've got a 3 by 3, but then we need to make it a cube. So it's going to be another 3 going backwards. Something like that. And now the question is, how many cubes are inside this cube? And if we have a 9 on the front, and then 3 layers of that going back, that's sort of like 9 times 3 is 27. So 3 cubed would give us 27. Another way this type of problem can look is where you know the base and you're trying to find the exponent. So the question here is, how many 7s multiplied together equals 343? So 7 times 7, we could try that. That just gives us 49. Okay, that's not enough. We can try another 7. So 7 times 7 times 7. That would be 49 times 7. And 49 times 7 is, in fact, 343. So 7 times 7 times 7 equals 343. That means that 7 cubed equals 343, which means that that x from the beginning up there equals 3, because that was our missing number. All right, now let's combine this with some order of operations. So some of you have learned order of operations using the acronym PEMDAS, which stands for parentheses, exponents, multiplication, division, addition, and subtraction. We can also model this using a triangle. I sort of like the triangle model because it really shows that you're doing multiplication and division at the same layer and addition and subtraction at the same layer. The way this works is you would start at the bottom and work your way up. So let's try it. So first, we're going to look at this. We're going to see what we got going on here. We got some parentheses, we got exponents, we got multiplication, addition, subtraction, more addition. That's all the stuff we have going on. So the bottom layer of our triangle is parentheses. So that means we look at those parentheses first. And within those parentheses, we have to decide what to do. Well, there's subtraction, multiplication, and an exponent. Exponents is the next layer on our triangle. So that's going to be the thing we do first. So 4 squared, that's the same as 4 times 4, is 16. Now we rewrite the whole layer. So it looks like that. Notice I just rewrote all the numbers and I replaced the 4 squared with the 16. Okay, now we're still doing the parentheses. So now I have a subtraction and an addition. Well, whenever you're faced with two things that are the same layer, you always go from left to right. So we're going to do the subtraction first and then the addition, because this one's first in the way this equation is written. So 40 minus 12 would give us 28, and then plus 16. And I think it's okay to do that all at once right now without having to rewrite it first. That would give us 44. All right, now we're going to rewrite. And I put those parentheses in there. We don't really need them anymore though, because there's only one number on the inside. So I think we're okay to leave those off. Then we can do our next step. So we have a multiplication left and an addition left. And multiplication and division happen before the addition. So we'll do that part next. That gives us 88. And then plus 1 is our last step, gives us 89. All right, now it's your turn. Go ahead and try this order of operations problem. If you've forgotten which step to do first, just go rewind 1 or 2 minutes so that you can see that triangle that we did showing which steps to do first. Good luck.